All right. Get coming in out of the rain. All right. Let's see if our new approach yields some results here. So we're going to do the first 10 problems on that test, and we're going to do 3 in a row. Yeah, you're welcome to try the first one on the board here. This is going to be finding 3 points on this line, and then we'll do another 2 like it. And if you've got this down pat, then you can skip to the next problem. But we're going to make sure that we get a good deal of practice, repetition right now on every problem. So we're going to, that's on that test. So homework tonight is the first 10, and then the next 10, so on and so forth. Okay. And then we'll see where we're at, see if we can make some gains that way. So I got a marker here, and I'll put a problem here and then another 2 just like it. And we'll see how we do. All right, so you're looking at the letter X, which stands for some number, random, variable, lots of change, lots of numbers out there. We can put them all in, and then you're just doing a calculation, and you're seeing what you get. So it would seem that if you're subtracting 6 as a first operation, making a 0 is helpful here. So let's replace X with 6. 6 minus 6 is 0. 5 halves times 0 plus 10, I guess. Looks like we got 10. It says change your x's by 2. So let's put an 8 in. 8 minus 6 is 2. Now, this multiplication and division are inverse operations. They're just as intellectually, what word do I want to use? Well, they're the same. I mean, you can do it in any order you want. So we can say 5 times 2 is 10, divided by 2 is 5. Or we could have done 2 divided by 2, 2 divided by 2. Well, that's 1, and 1 times 5 is 5. So it doesn't matter when you're looking at something like this, whether you go in this direction, right? Or the other way around, you're going to get the same answer. So this 2 here really is no different if I place it there. And so hopefully we're seeing that cancellation and making numbers smaller than bigger. All right, so if these 2's cancel, then 5 plus 10 is 15. What can we learn from that? Let's go back to x minus 6. Let's make sure we see this. Okay, there's your change in x. We use a triangle to measure, to imply change. And over here, we got change in y, right? And the change in y is always in the numerator, and the change in x is in the denominator. Well, that pattern should continue. Linear functions. Rise or run, rise, rise, rise. Change in x, change in y, change in x, change in y. It's constant. If it's constant, then we should be able to do this ad infinitum. What am I doing? Okay, should be able to do that forever. All right. So now you try another one. You try minus 2/3 x plus 7 plus 9. And I'm just going to put the answer here, but you're trying these on your own first. I see -7 is useful, friendly, very friendly. And if I put it in, I get 9. Positive 9. I get whatever this is. Whether it's positive or negative, that's what I'm going to get when I make a 0. All right. So again, change in x. That means I'm going up 3, and I'm going down 2 for the y's. So down 2 for the y's, there's 7, there's 5, there's 3. I can do that forever. Up 3 for the x's, -4, -1, and what? Positive 2. So we get a little arithmetic practice there. Nothing wrong with that either. Now, keep in mind, this positive 9 here could have been written on the other side. Addition of 9 on this side could have been written as subtraction of 9 on that side. And oftentimes, this is how textbooks will communicate to you a linear function. I much prefer the 9 here. I think it has a lot of advantages for being there, but could be that way. Now, occasionally I'll throw -4/7 just x, no parentheses, +5. Again, we want our multiplication to be 0. Right, that's what we did in the first two. We wanted our multiplication to be 0. So what makes multiplication here 0? Using 0. And if you use 0, 0 times anything is 0, you still get that. So it's really about picking that first number so that we get rid of the multiplication. We don't have to consider it. So we're always trying to make the multiplication 0. And then you get whatever the constant is for these polynomials. Okay. Now, how do we change from there? Same way we did the other two. Up 7, up 7, up 7. Keep doing that forever. Down 4, 1, -3, -7. Some good arithmetic practice. Okay, so that's going to be on every test. And I'm hoping that as you keep doing it, it becomes effortless. That's our goal. Our goal is to make problems effortless. MX plus B form. All right, well, notice when you write y equals mx plus b, there's no parentheses. Okay, how do we get rid of the parentheses? We do the distribution. Okay, we know that 2 times 3 is 6, and 2 times 1 plus 2 has to also equal 6. So we do the distribution, 2 plus 4. We do the multiplication, parentheses is gone, and that's 6. All right. So first step, bring the 5 to the other side. Okay, I won't skip any steps. I'll leave this alone, and I'll bring the 5 to the other side. If it's already there, you don't have to worry about it. Now we do the multiplication. Okay, and this number is getting multiplied times -4 and then divided by 7. So we can just write it like that. That's the distribution for that. And now we got -4 times 3 is -12. That's that. And you still got to divide by 7. And then you're going to add 5. All right? So these are not like terms. They're numbers. They're real numbers. But they're not like terms right now because the divisions aren't the same. And we have to make these divisions the same. So there's -4/7 x, -12/7 plus, well, I know I got to have a 7 there. What divided by 7 is 5. Now there's your times tables. Now I can combine them. This positive is bigger than that negative. So we're going to go down 12 from 35. -4/7 x, down 12 from 35. Little arithmetic practice, 23/7. Okay. Now, if I put -3 in here, -3 plus 3 is 0. 0 times anything is 0. I am going to get y minus 5 equals 0. Okay, y's got to be 5. And we can see it here more easily. -3 gets me 5. All right. So if -3 gets me 5, and all these equal signs means I could write that this way. I can write that this way. And I can write that this way. Then if a -3 gets you 5 there, then a -3 should get us a 5 here. All right, so let's put -3 here. Well, -4 times -3 is 12/7. 12/7 plus 23/7 is 35/7. They are all the same calculation. Okay, just you graph from a different perspective. That's what we're practicing. Okay, so if this was what I was given, and it's a slope and it's an intercept, I take the intercept of 23/7, which is near 3. So let's say that that's 23/7 for a y value, right? If I put 0 in, and what do? I go down 4. I don't know, maybe that's 4 units of change over 7, something like that. And there's the linear function. Whereas up here, the way it was originally written, -4/7 x plus 3. Well, I can see the point -3,5. That's why it's called point slope. So there, I would go to -3,5, which is here. On this graph, it would have been here, right? And what do? I go down the same slope. They're the same line. Right? That's all we're practicing. All right, so now I'm going to give you a couple more. All right, I am going to talk about each problem so that we're not just working mechanically. So let's say y, I'm going to move the numbers over every time. So let's say y is equal to 3/7 x minus 2 minus 5. All right, so you're going to put that in slope-intercept form now. All right, so what do we have? We have y equals 3/7 x minus 6/7 minus 5. Okay, both are negative, so I'm just going to add up the amount. So y equals 3/7 x. I have a function that's going up 3 and over 7 like that through the point 2, -5, but we're going to build it off of the number 0 now. So this is minus 6/7 minus 5. That's y equals 3/7 x minus 6/7 minus, I got to get stuff over 7. Oh, it's the same number again, huh? 35. So it looks, in this case, I have 3/7 x minus 41 over 7. And I hope you can see the y-intercept of 0, -41 over 7, which is near -6. Okay, that's a point on a curve. And I'm going up 3 and over 7, which we described over here. So this is slope-intercept. The intercept is 0, -41 over 7, and I have a 3-to-7 ratio of change. 3-ish, 7-ish is about maybe it's a little lower here. That looks like about a 3-to-7 ratio of change. There's a slope, there's an intercept. That's why it's called slope-intercept. All right, we'll do one more. Okay, one more here. Remember, you're pausing the video and you're doing it. I'll just do the mechanics this time. No need to talk anymore. So y equals, how about we do -3/5 x plus 2 plus 4. All right, so -3/5 x minus 6/5 plus 20/5 equals -3/5 x minus 6 plus 20. That's a bigger positive than the negative. So that's the same as saying 20 minus 6, which is 14 over 5. Okay. All right, moving right along. Problem number 3. All right, if we can name a bunch of points on a line from the equation, then if we have a bunch of points, we should be able to go backwards. Okay. All right, so I like to write my x and my y in tabular form. Okay, I think it's a little more helpful for folks to see. And so we're always just going to take the first. It doesn't matter, we could take the second, but let's just take our first data point. And what would create 8 to 2? Always subtraction. So if that's 8, you're going to say x minus 8. If this was -8, you would have said x plus 8, because subtracting a negative is addition. But I originally gave you 8, 2, so I am going to go back to get rid of that number. When you put it in, it's now going to convert. We're going to make it convert to a y value of 2. I wish textbooks would put the y over here, state the calculation, and then I think you can see your y value more easily. 8 minus 8 is 0 plus 2. Okay, 2 is our y value. Maybe I wouldn't do that. I don't. Right now we're here. Okay, and what we were doing before was looking at the change. Okay, I can see that's 7. And looking at the change, that's certainly going down. That's what we're trying to learn how to do. So I'll give you 2 more now. All right, effortless effort takes effort. All right, so let's look at -4, 7, and 8, we'll go 9, 22. Okay, all right, so this is gone now. And if we don't need to put it in tabular form. If we want a -4 to get a 7, then x plus 4 is what you're going to say to get rid of that number. We add, get rid of subtraction of 4, do addition of 4, bring in the 7. Okay, now you got to remember there's your first x, there's your second x. So change in x, change in y. Maybe I'm going to put the x values underneath because it's rise over run is what you've been taught. That x to that x, and this y to that y. Maybe we'll do that every time. 7 to 22 is 3, 13, 15. That's in the top spot. In the bottom, -5, -4 to 9 is 13, up 13. That's that equation. And one more. All right. Now, you could put it in slope-intercept form, but it's so much harder. Right? I know some of you got drilled to do mx plus b. For how long? I don't know. But nobody uses it as you go up the ladder in math. Well, that's not true, but to write the equational line most quickly, nobody uses it. Okay, so let's look at -2, 8, and let's look at, I don't know, 15, 29. What do we got? What gets rid of subtraction of 2, addition of 2, bring in the 8. There's our x to x. That's going to be underneath. So that looks like it's up 17. And from y to y, that looks like 21. There's your equation. All right? All right. Now we're just going to do a little solving. And we want to not have to think. That's the goal. We just want to be able to have the mechanics down and have some confidence in it. Okay, so we have a number times -4 sevenths plus 2 equals -10. I'm going to graph the left side of that equation. I'm going to graph y equals -4 sevenths x plus 2. That's slope-intercept form. The intercept is 0, 2. And I'm going down 4, which would be about there, and over 7, which would be about there. So I have a line that looks like data points lining up here. I want to hit -10. Well, -10's here somewhere, right? This is -10's down here somewhere. So that's going to intersect at that x value. What is that x value? What is that one? What do you think it is? That's 2 units. That's pretty reasonable for -10. That's 2 units. How far over did I go? I don't know. It looks to be about 10 or 12 units to the right. Let's find out. Okay. Well, I know this has to be 12, right? I'm sorry, it has to be -12. This whole thing has to be -12 because -12 plus 2 is -10. So, okay, what's our first step? The first step is to move the 2 to the other side. Oh yeah, there's our -12. There's our -4 sevenths x equals -12. Now, algebra 1 probably taught you to multiply by the reciprocal, which is -7/4. That takes some thinking. That takes some work working with. What's easier? Well, let's take a look at a fraction here. 5 divided by 2 into 6. All right, 30 divided by 2 is 15, or 3 times 5 is 15. Either way, but we know that to be true, right? What I'm suggesting you do is you take the division by 2 and you move it to the other side. Boom. 30 equals 30. Okay, there's 7. I'm going to move it to the other side. Boom. Division became multiplication. And now, I never like to divide by negatives. I always just do that. -84, +84. Obviously, you don't have to, but I like to. And then you can see that 21 is your x value. Let's put 21 in. 21. Well, I know 7 goes into 21. I mean, I could multiply and then divide, but I'm going to divide and then multiply. 3 times -4. Oh, there's our -12 plus 2. It works. So let's do those using inverse operations. I hope in class I remember to say on the homework, pause the video. before I get on a roll. All right, so let's try this one. Let's try -6, let's do sevenths x minus 4 equals 20. Now I'm going to make something that's integer friendly. So let's make it 4 and 4 to 23. All right, let's do that instead. All right, so you're pausing, and I'm just going to go -6/7 x equals 23 plus 4, which is 27. Oh, I didn't make an integer friendly, did I? No, I did not. That's okay. -6x is equal to 27/7 times 7. Sorry. I got a little tired here. 27 times 7. I didn't feel like working that hard. All right, here's a little trick of the trade. To do that without a calculator, you want to rewrite 7 times 20 plus 7. Okay? So that's 140, and that's 49. You can kind of do that in your head. 140 plus 40, 180 plus 9, 189. Might strengthen your skills a little bit. All right, so this is 189. -6x equals 189. And obviously we can put the negative in the numerator, divide by 6. And I was trying to give you an integer friendly number, and I struck out. Let's try another one. Let's try 8 over 3x minus plus 4 equals 7. All right, so what's your first step? Subtract the 4. There you go. So now you got 8/3 x equals 3. Multiply by 3. 8x equals 9. Multiplication becomes division on the other side. All right, and there's your practice for that problem. Our goal here is on the next test, when I put all these problems on the next test, that you're going to get 10 problems right there. And then tomorrow we're going to do another 10 from the test, maybe even on Monday. We'll see how it goes. We'll see how it goes. All right, so if I can get this, what's the best way to do this? All right, get this chair out of the way, bring the desk this way. There you go. Tilt the camera. Hopefully we can see. Yes, we're in good shape. All right, so we're going to do the squaring, then the multiplication, and then the addition of 5. So I'm going to do 2x plus 5 out, and then show you what I hope you can do. So 2x times 2x. Let's look at this first. Let's look at 2 times 7 is 14. We know that to be true. 2 could have been written, let's make it 3. 3 times 7 is 21. Okay, so the number 3 could have been written as 1. Get more sleep. 1 plus 2, and 7 could have been written as 3 plus 4. Well, I like that one. So let's do the multiplication. The first thing we do is not the 2. We do the 1 times 3 is 3, and 1 times 4 is 4. Then we do the 2 times 3 is 6, and then we do the 2 times 4 is 8. And when we add that up, 7 and 14 is 21. And we can see that the foiling process, first, outside, inside, last, whatever that means. We just did it. All right, so we got to do 2x times 2x, which is 4x squared. We got to do 2x times 5, which is 10x. We got to do 5 times 2x, which is 10x. And we got to do 5 times 5, which is 25. So what this is saying is 4x squared plus 20x plus 25 is identical to 2x plus 5 squared. Now, if you're putting numbers in, it's actually easier to work with this right now. Okay, it's easier to do that. But let's put the number 1 in. If I put 1 in, I get 4, 24, and 25. I get 49. Oh, you know what? That is a nice square, isn't it? And if I put 1 in over here, I get 2 plus 5 squared. Oh, yes, they are the same calculation. 7 squared, 49. And what I've been asking you to do is to see if you could spot what we just did, which was 4x squared plus 20x plus 25 Can you see the pattern emanating from that so you don't have to work so hard? Because you put some time in and say, okay, I'm going to square the first term, which has two parts. I got to square each part. Ah, yeah, there was a 10x. I shouldn't have erased it, but there was a 10x and it showed up twice. And I'm squaring the last term. All right, that's going to speed up your calculations if you can see that. Save yourself some time over the course of your high school career. 5 minus 3. You might want to, the next time you do this, move that 5 immediately to the end. Right? Every number, every positive number is really multiplied by positive 1. We just don't write it. Right? Every negative number implies that you're multiplying by negative 1. We don't write that. We just simplify it with the two strokes of the pen. All right. So we got minus 12x squared. We got minus 60x. We got minus 75 plus 5. Okay, you got minus 12x squared, minus 60x, minus 70. You got to be careful with your arithmetic. Let's try another one. Let's try 3 plus 2 times x minus 4 squared. Okay? 2 times, remember, you can do x minus 4 times x minus 4. Feel free to do it out like that. I'm going to get x squared. I'm going to double the product. I'm going to add positive 16. And then I'm going to add the 3 at the end. And you should get 2x squared minus 16x plus 32 plus 3. Save a little time here. I'll write 35. One more. Minus 5 minus 2, 3x minus 1 squared. Okay, so I got minus 2. I'm going to do the squaring with a bracket. 9x squared. I'm going to double that product. Minus 6x. I'm going to square negative 1. Plus 1. And I'm going to bring the minus 5 to the end. Final answer. Minus 18 squared. Almost forgot to write the square. Positive 12x. Minus 2 minus 5. Minus 2 minus 5. Be careful with it. Minus 7. See it on a bunch of tests. All right. Putting this in graphing form. Some of you actually, you could factor out an x here. You can. I'm going to do it by factoring out an x just to show you what some of you did, but maybe didn't interpret properly. If you take out an x, you got 4x minus 40 plus 7. There's actually some good information that comes from this. X could be 0. 0 times anything is 0. Plus 7 is 7. Or x could be 10. I mean, it could be any number, right? But those are critical numbers because they make zeros. If I drop the number 10 in here, I get 40 minus 40, which is 0. Then we do the multiplication. 0 times anything is 0. And I get 7. That's actually very helpful. I have two places on a curve. I have 0, 7, and I have 10, 7. Oh, I should have put that on the other side. I have 0, 7, and I have 10, 7. Well, what does that imply? Cup shape up, yes? Let me get rid of the x-axis because I really don't know where it is at the moment. But I got a cup shape up. Well, that's really helpful. That's really helpful. Okay. That tells me that my x value here is right dead smack in the middle between my first and second x's. That tells me it's 5. Then I can go back to either calculation and put a 5 in it. It's probably easier to put it in there. If I put it in here, 5 squared, 25 times 4 is 100. If I put 5 in here, I get minus 200. And then I add 7. Well, that's minus 100 plus 7. Minus 93. That's great. Minus 93. All right. So, I mean, I even know my roots. I know a bunch of stuff right now. I know my, well, let's not, do I want to, no, I'm not going to go any short. We're just trying to learn how to do this. Okay. Now, you can do that. And I hope you can see that minus b over 2a equals 5. So let's go up and do that. Minus b, which is positive 40, over 2 times a, there's your 4. 40 divided by 8. Yeah, that's 5. Right? That's another way to do this problem, and we'll do it that way because that's what we've been spending most of our time on. But there's useful information that comes from this. All right, so how are we doing it? If we're looking at, remember, when we're graphing quadratics, we need the vertex and the y-intercept. I'm going to say that every single time. Vertex and y-intercept. The y-intercept is given. It's 0, 7. It's right there. We're 1 point away from being able to graph this and put it in graphing form. All right, so y is equal to a, x minus 8 squared plus k. That's the graphing form. And a is given. It's a 4. You already have it. So the only thing we need is the vertex. And that's the vertex is represented by hk. And h is represented by minus b over 2a, which we just did a minute ago. We know it's 5. And what do? Addition of 5, you subtract. All right, now we got to find k. Well, k is a y value when you use the number 5. And we just did it a minute ago. We had 100 minus 200 plus 7 minus 93, we said. And 0, 7's on this side. It's actually on the decreasing side. Okay, you can always look at the middle term. We'll know which side your y-intercept's on. All right, so that was kind of a piecemeal process. But now I'll give you another one. And this one I'll give you as a cup shape down, right? Because it's negative, minus 2x squared plus 20x minus 3. Right, you pause the video and see if you can put it in graphing form and sketch it. And I'm just going to do it now. So graphing form and sketching it. So I need minus b over 2a. That's my x value. And in this case, it's minus 20 over 2 times negative 2. Negative into a negative is a positive, 4 into 20. Oh, we got the number 5 again. Okay, so how much of this do I have right now? I have minus 2. I put 5 in the wrong column. 5, okay? X minus 5 squared. That's what we have at the moment. Now we're going to drop a 5 in. Minus 50 plus 100 minus 3. Minus 50 plus 100 is positive 50. Minus 3 is 47. Positive 47. Okay, this is helpful. I can see I have a cup shape down. I can see 547 is the vertex. And I know I'm on the upside. Right? You read functions from left to right as to whether they're increasing or decreasing. This increases. My y values are getting bigger until I hit x value of 5. Then my y values accelerate down. And the y-intercept is negative 3. And it's on this side. That's the graphing form. That's the sketch. I mean, I also know that 10 gets me negative 3 because of the symmetry. That's called the axis of symmetry. Let's do another one. Okay, let's do 3x squared plus 24x minus 7. All right. Minus b over 2 times a gets me negative 4. Negative 4 means I'm going to write x plus 4 squared. I already have the a term. It's positive, so I know I have a cup shape up. And I'm on the increasing side for the y-intercept, which is negative 7. That's the increasing side. So 0, negative 7 tells me that I have an x value that's negative 4. I'm one step away from the graphing form. All I need is the k value, which is the y value at this location. And I need the y value. So I plug in -4. -4 squared times 3 is 48. -4 times 24 is -96. Notice it's always twice that and opposite. -7. When you add these, you always get that number, but change the sign. When you add those first two, and then -7 gets me -55. Okay. Theoretically, if we went from the equation to a graph, we should be able to go from a graph to an equation, which is what we're going to practice over here now. Here. It's a lengthy practice here. But effortless effort means that we do it just once, 10 problems in a row. Eventually, we should be able to do it correctly and quickly. Oh, 2, 9 is the vertex. What can you immediately say? Hope you can say that with practice. So then the only thing is, how do I get this A term? Well, it really is the change you get when you put the next number in. The next number is 10. Well, 10 minus 2 is 8, but this isn't linear. That 8 units is being squared. So right now I have 64 plus 9. That's not equal to 16. This number stinks. Let's get rid of it. What can I add to 9 to get to 16? 7. There's the conversion. I got to make the numbers work, and I got a marker. I'm going to make it work. Let's try another one. Let's try -5, 2 for 20. Okay, this is the vertex. Oh, I guess I want to say x plus 5 squared plus 2. I'm going to drop the second x in. Second x is putting a 4 in here. That's 9 squared. That's 81 plus 2. Let's see if that equals 20. I don't think it does. I think I'll get rid of that number by dividing it out of the problem, because I want the number that does work. How do I get from 2 to 20? 18. I suppose you should divide by 9, reduce the fraction. But that's not what we're highlighting right now. Leave it like that. I don't care. We just want proper numerics. Let's try one more. Let's try, I don't know, how about 3, -10? That's your vertex. And let's go to, it doesn't matter if this number is even smaller. Let's make it -5. And let's go to 100. You see the vertex? I hope you write x minus 3, get rid of addition of 3, and bring in -10 because it works. That's why we do it. Drop in the next number, which is -5. -5 minus 3 is -8. -8 squared is 64. Is 64 minus 10 equal to 100? I think not. I don't think it is equal. I'm going to get rid of that number. What am I going to bring in? How do you get from -10 to 100? You got to go up 110. That's that equation. Now, what if we have an equation in graphing form? We have an equation in graphic form right here. What do I see? I see a cup shape. I see 4, 5. And if I put a 0 in here, I get 53. 0 gets me 53. Zeros to the left. 0 gets me 53. That's what this graph is on the left. I'm not looking for 53. I'm looking for what x values get me 32. All right? Looks like some x between 0 and 4, and therefore probably something between 4 and 8. You get two answers like that. How can I get them quickly? Well, when you solve equations, you end up with x equals. That means everything's got to go to the other side. Now, if I have this alone, I don't have to do any factoring or anything else. It's surrounded by mathematical operations. So you just take addition of 5 and move it to the other side. When you see it written in this form, 27, then you divide by 3, 9. Then you take plus minus square root. So you get x minus 4 equals plus minus 3 because taking the square root of 9. And then you say x is equal to 4 plus or minus 3. So one of your answers is 4 plus 3, which is 7. And the other is 4 minus 3, which is 1. And we said one of our answers would be between 0 and 4 and the other between 4 and 8. You always plug the number in and see if it works. Let's put a 7. 7 minus 4, 3. 3 squared, 9. 9 times 3, 27 plus 5, bingo. All right, so let's do another one. Sometimes they're nice answers, sometimes they're not. Let's do a minus 2, x plus 6 squared minus 5. And let's have that equal negative 11. What's your first step? Add 5, negative 6. Boom. What's your next step? Divide by negative 2. Boom. What's your next step? Undo squaring with plus minus square rooting. Boom. What's your last step? Addition of 6 becomes subtraction of 6. Okay, that's what you got. This number's negative 6 plus or minus approximately 1.73. Just to get a feel for what the x values are. All right. Now, sometimes you get imaginary answers. I'll give you one that's an imaginary. Let's do 4 times x plus 2 squared minus 5. I'm going to set that equal to negative 20. Okay? Because I know this is cup shape up. And I know negative 2, negative 5 is the vertex. That number's not on this graph. It's much lower. It's a constant. Height of 20, negative 20. Okay, so I know I got to go down 15 units to get there. I know I got to do a little division by 4. Let's see all those inverse operations materialize, and let's answer with an imaginary. So I'm going to add 5, negative 15. I'm going to divide by 4, negative 15 over 4. I'm going to do plus minus square root to get rid of the squaring, plus minus. When you see this situation, we take the negative symbol out and we simply say, hey, that's an imaginary number. And the last step is to, x plus 2 is where we're at the moment. So x is equal to negative 2 plus or minus the square root of 15 over 4 I. Now, 15 over 4 is pretty close to the square root of 16 over 4, by the way, which is equal to the square root of 4. So, you're adding plus or minus 2 here. All right. But the range of this thing was y values bigger than negative 5. You can see this, I think. I got to move it this way, otherwise I be writing left-handed so you can see. Bag out of the way. Last problem. So this is a Pythagorean relationship. Always cut the middle term in half. And when you square, you got an extra 4 for baggage. Take it away. Cut the middle term in half. Whatever number you square, get rid of it. Move your constants to the other side. I now know that I have a circle whose center is 2, negative 5. Those numbers will make 0. 0 doesn't equal 100, but it's the center of the circle. And I know I'm going up 10, left 10, down 10, right, left 10, right 10. Okay, so what points do I have? Well, I got my domain and range. All right, so 10 in this direction is negative 8, negative 5. Right, I'm going to highlight negative 8. Over here, I got 12, negative 5. So what's my domain? Negative 8 to 12. That's my horizontal distance. Negative 8 to 12. So we would write that as x values less than or equal to 12, greater than or equal to -8. Next time I'll do the range. New problem. You can get started on it while I erase. Let's do x squared plus 6x plus y squared plus 10y. And these numbers don't have to be nice, but I'll try to make them nice for you for starters. So 9 and 25, 34 will make it a 2. Okay? So you start doing that. And this is what you should have written. X plus 3 squared minus 9 plus y plus 5 squared minus 25 equals 2. X plus 3 squared plus y plus 5, thank you, Pythagoras, is equal to 36. I have a circle centered at -3, -5. Yeah, they were both positive. -3, -5. If all I want is the range, I'm going to go up 6. That takes me to 1. I go down 6 from -5, -11. So I now know my range. Y values less than or equal to 1, greater than or equal to -11. That's how you'd write the range. Okay. So center at -3, -5, radius of 6 is all I'm asking at the moment. But we are going to start to locate these positions, right? And so you don't change the x value when you go up and down. You don't change the y value when you go side to side. -3 plus 6. These numbers would work in the original equation and in this one, certainly. -3. Probably good to check. So let's show how it works here because it's, oh no, I added the 6. Boy, I'm tired here. What did I do differently here? Brain has just stopped working. Oh yeah, I'm plugging this in here. So there's your 3. It was always working. I'm plugging -5. I had a little dyslexic moment, right? So that cancels, and there's your 6 squared equaling 36. Yay. Okay. See if I can get my neurons to fire again. They stop for a moment. Catch my breath. Give you a new problem. You get the center and radius. Okay, let's look at, I already put it in parentheses. X squared minus 10x plus y squared minus 12y. And let's make that equal 25 and 36, 25 and 36, 61. Let's make it 3. I think that's friendly. If it's not, we'll deal with the radius, whatever it is. X minus 5 squared minus 25 plus y minus 6 squared minus 36 equals 3. If I correctly added, I'm hoping that's 64. So I got x minus 5 squared, Mr. Pythagoras, y minus 6 squared, which means I'm creating a triangle. X minus 5 is the side of that. Y minus 6, you're looking at the area statements, and this is 8, right? And that hand of the clock, 8 units, 8 units, 8 units, 8 units. That area of this side isn't changing as I draw the triangles in the different quadrants. Center, 5, 6. Radius, 8. We're done. And I'll be interested to hear your commentary Tuesday morning after you did this assignment. Okay, I did a lot of talking there. Hopefully, by the time you did the third problem each time, had a little more success. That's the hope. We'll get some feedback from you. And if you didn't get more success from this, we'll find another approach. We'll keep changing approaches until we match an approach to your learning style. All right, ciao.